Welcome to The Explainer. Today, we're diving deep into the world of digital detective work, and we're going to zero in on one of the most information-rich artifacts you can find on any Windows computer, the registry. You know, this quote really gets to the heart of it. The registry isn't just some boring technical configuration file. Nope. For a forensic investigator, it's basically a digital diary. It's a detailed logbook of almost everything that happens on a computer, from the moment it boots up to the very last file a user ever touched. So, to really get this, we're going to go on a little digital investigation of our own. First, we'll survey the crime scene. Then, we'll go deep inside the database to see how it's structured. After that, we'll learn how to spot the actual digital footprints that get left behind, check out the specialized toolkit investigators use, and finally, see how they piece it all together to reconstruct the entire story. Okay, so let's set the scene. You have to think of the registry as the absolute primary source of evidence. It tracks everything: who's been using the computer, what programs they've run, network connections, and get this, even devices that were plugged in years ago. For any investigator, it's pretty much the first and often the very last place they look for answers. So how is this digital evidence locker actually structured? I mean, if you want to find the clues, you've got to understand the layout, right? It's key to knowing exactly where the most valuable pieces of information are hidden. So at its core, the registry is really the central nervous system for the entire Windows operating system. And it's not just one giant file. It's actually a collection of files, all working together to organize every little setting and option needed to get the system configured for all the users, all the software, and all the hardware. And it's organized in this tree structure that's actually a lot like a file system you'd see anywhere else. It all starts with these large database files called hives. Then inside the hives, you have keys and subkeys. You can just think of them as folders and subfolders. And finally, inside those keys, you find the values. And that's it. That's the actual data, the settings themselves.
Now, this is where it gets really interesting. Different hives store very specific types of evidence. For instance, the system hive tracks all the hardware, like every single USB drive that's ever been connected. The software hive gives you a list of installed applications. But if you want to track a specific person's actions, the ntuser.dat file is the absolute jackpot. It records a user's program history, recently opened files, even paths they typed directly into Windows Explorer. It's honestly the closest thing you'll get to a digital transcript of their actual behavior.
But here's the thing. The registry isn't static. It actually operates like a transactional database. So when a change is made, Windows doesn't just write it to the main hive file right away. Instead, it first jots down the changes in these little log files as what are called dirty pages. Just think of it like writing something in pencil in a notebook before you commit it to ink. It's a safety mechanism to prevent corruption. So what happens if an analyst overlooks these logs? I mean, it sounds like a pretty minor technical detail, right? But ignoring them can be a massive, case-breaking mistake. Well, if you analyze a dirty hive without replaying those logs, it's like trying to solve a puzzle with a bunch of missing pieces. The most recent and often most crucial evidence, like a malware entry that was created and then quickly deleted, might only exist in those logs. So you're not just looking at incomplete evidence. You might be missing the digital smoking gun entirely. Okay, let's move on and hunt for the actual digital footprints, the artifacts that investigators are looking for. These are the specific records that really build a case and start to reveal the story of what happened on a system. So, to prove a program was actually run, investigators look at artifacts like user assist. This one is probably one of the best for proving a user intentionally launched a program from the graphical interface. And then there are others, like run MRU, which shows you exactly what commands were typed into the run dialog box. And what about accessing data? Well, artifacts like shellbags are just fascinating. They store folder viewing preferences, things like icon size and window position. But here's the key. A shellbag entry can stick around long after the folder or even the entire external drive it was on has been deleted. It's like finding a digital ghost of a folder, proving it once existed and that someone was looking inside it. Now this is where investigators often go hunting for malware. See, malicious software needs to survive a reboot, right? So it achieves what's called persistence by modifying specific registry keys, like the run and run once keys, to make sure it automatically starts up every single time the system boots. Finding entries like that is a classic sign of a system compromise. Of course, you can imagine manually digging through millions of registry entries is pretty much impossible. So, to do this work effectively, investigators rely on a whole specialized toolkit. And these tools, they generally fall into two categories. On one hand, you have deep dive viewers like Registry Explorer. Think of these as a microscope, letting an analyst manually inspect every tiny detail. And on the other hand, you have automated triage platforms like Autopsy, which are more like a scanner, sucking in an entire disk image to automatically flag the most interesting artifacts and give you that high-level overview. Let's just look at three of the most powerful tools out there. You've got Registry Explorer, which is kind of the practitioner standard, famous for its plugins that can decode really complex data. Then there's Autopsy, an amazing open source platform that's great for putting registry data into a larger case timeline. And then there's Registry Recon, which has what you might call a truly unique superpower. This quote really highlights Registry Recon's key advantage. It's basically a form of digital time travel. It doesn't just look at the current registry files. No, it scours the entire disk, including all the deleted space, for fragments of old data. It can actually resurrect deleted keys and even rebuild entire registries from Windows installations that are years old, letting an investigator see exactly how a system changed over time. It's incredible. Ultimately, though, registry forensics isn't just about finding all these individual artifacts. It's about taking all of these fragmented little clues and weaving them together into a coherent story. The ultimate goal here is correlation. This is where an investigator connects the dots. They'll link a USB device ID from the system hive to a user's file access log in their ntuser.dot file. They'll match a program execution timestamp from user assist with a file creation event from the file system. It is all about building a defensible timeline of events, piece by piece by piece. In the end, what you're left with isn't just a pile of raw data, but a narrative. It is the detailed story of how a computer was used, what a person did, and the digital traces they left behind. So, we've seen how the registry is this persistent, incredibly detailed record of nearly every interaction with a computer, which really just leaves us with one final thought. If an expert were to look, what story is your registry telling right now?